Okay, this is section 4.8. We are going to be talking about applications of right triangle trigonometry. We are not going to be doing the oscillating motion or simple harmonic motion. That's for physics class, if you take that. But we are going to be doing angles of elevation and depression first. And we're going to be using our right triangle trigs, sine, cosine, and tangent, to solve word problems. Personally, I think these are some of the easiest word problems because if you draw the triangle, it's just sine, cosine, tangent. Um, so two things, you need to know some terminology. Looking horizontally, or the ground, is the horizon, and that is always horizontal. The horizon is always horizontal to the ground, and we're always going to measure things off of, say, flat ground. And so these two lines are parallel. So if I draw a triangle in here, right here is called the angle of elevation. It's measured to the horizontal and it's going above. Usually it's off the ground, but it could be off of some horizon line looking out with your eyes. Angle of elevation just means it's above the horizontal. And maybe I can spell elevation right. And then here we have the angle of depression. Okay. And so when we hear those terms, that's what it means, and that's going to be helpful in drawing our triangle. So the angle of depression of a buoy from the top of the Barnett Bay Lighthouse is 130 feet above the surface of the water is 6 degrees. So the angle of depression is 6 degrees. 130 is the height of the lighthouse. Find the distance x from the base of the lighthouse to the buoy. Okay. So anytime we have a problem like this is example one. We know we're 130 feet high. Our angle of depression looking down is 6 degrees. And out here is my buoy. I don't usually draw things nicely. Oops, I misspelled buoy. I just draw the triangle. Um, Something to note. There's a property from geometry when I have parallel lines, these two angles, the angle of elevation and the angle of depression, are alternate interior angles, meaning they're equal. So this angle right here in the triangle, because I need an angle in the triangle, is 6 degrees. I could also call this one 90 minus 6 because the angle between a vertical, and keep in mind that the height of a lighthouse is vertical. All heights pretty much are vertical, which give me this 90 degrees. I could also call that 84. That actually might be easier. So right here, I have 130 and I want x. X is the distance. Keep in mind what they ask for. The distance, they're asking the distance from the base of the lighthouse to the buoy. If they asked for the distance from the observer to the buoy, we would have to do the hypotenuse. We'll call that y, which we don't have to solve for in this problem. But here they asked me for the base. That's 130 feet. So this is opposite and adjacent. If I use 84 as my angle, so opposite and adjacent is a tangent. If I use 84 as my angle, I get x over 130, which is easier because it can just multiply both sides by 130. And I'm gonna grab calculator. I get this is a distance of 1,237. I'm going to round to the nearest whole number, feet. Okay, and again, it asked me the distance from the base of the lighthouse to the buoy. It's important because that told me I was solving for X, not Y. Okay, making some indirect measurements. From the top of a 100-foot tall building, this is example 2. I'm just going to start drawing it. Now, they give you a picture in the book, which is kind of nice. Um, but it doesn't always happen. 100-foot tall, L-Gil tall, a man observes a car moving towards the building. If the angle of depression of the car changes from 22 to 46 during the period of observation, how far does the car travel? So this means ultimately I have 2 triangles here. And again, I have my artificial horizontal. My building is 90 degrees to the ground. This is 22 degrees. This is 46 degrees. What I'm looking for here is X that goes from here to here. What I'm going to do to get that is find Y, the total distance on the bottom of the 22-degree triangle, and Z, the distance on the bottom there. So that's 46. This interior one is 44. Again, I'm using this side. Well, I'll do this one. 22 here, 46 there. I'll do the 22 for a second and show you why I'm going to use the top ones with 44 and why I did the 90 minus trick. Because this is 90 and I can just do 90 minus to get the inside angle on top. So the bottom one, so the outside one, tangent of 22 is going to equal 100 over y. To solve this, I'll make that a little neater. To solve this, I'm going to multiply both sides by y. Okay, and then I must divide by tangent of 22. So I'll write that out. I'll write out that I multiplied by y on both sides here, which cancels my y's on my right. Y equals 247.51. Now for the other one, I need to get z. I'm going to use the 44 because opposite is now z. And now I can multiply both sides by 100. And it just saves one step of writing. Does it? Tangent of z. Tangent of 44. I said 44. That's what I meant. Tangent of the 44-degree angle gives me z on top, so opposite z over 100. That just saves one step. It's not really a big deal, but I like to save as many steps as I can. 96.57. 57, not 5z. 96.57 feet equals z here. So I want x. X is what I want. And x is just equal to y minus z. So y was 247.51, z is 96.57. And that gives me x. The distance the car traveled was 150.94 feet, or probably round that off to 151 feet. They did 150.9 in the book. Okay. So let's make that a little neater. That works out like that. Okay. So the key here was find both triangles and think about what they're actually asking you to draw. Example 3, finding a height above the ground. A large helium-filled penguin, again, you can see this picture in the book, is moored at the beginning of a parade route, waiting the start of the parade. Two cables attached to the underside of the penguin make angles of 48 and 40 degrees with the ground and are in the same plane as the perpendicular line from the penguin to the ground. The cables are attached to the ground 10 feet from each other. How high above the ground is the penguin? So up here is my penguin. This is going to be 40 degrees. This one is 48. And this distance here is 10. This right here is my height. That's what I'm trying to solve for. I'm going to call this distance x. So this distance right here is x plus 10. I'm using it as that instead of y to save myself a variable. Again, we're using a lot of these word problems, we use tangents. We know that tangent of 40 equals h over x plus 10. We also know that tangent of 48 equals h over x. And what I'm about to do here is I'm going to got two equations and I have two variables. So I'm going to set them both equal to h and by multiplying both of them by the denominator. The first one, x tangent 48. And once they're equal to h, I can substitute or set them equal to each other. X plus 10 tangent 40. And so I'm going to set them both of these equal h now. And I'm going to solve for x first, which is going to be a little bit inefficient, but then I'll use that to solve for h. So x plus 10 tangent 40, 40 equals x tangent 48. And I'm going to distribute x tangent 40 plus 10 tangent 40 equals x tangent 48. I'm going to gather my two terms with an x in them to the same side. So that means I subtract x tangent 40. So I'm just using equation solving from, algebra 1 level or integrated 1, depending on what you took. But it looks harder because it's x tangent 40 instead of 3x. But it's the same principle. Gather my x's together. Now, the hard part is I can't just add x tangent 48 and x tangent 40 like I would 2x and 3x. I mean, I suppose I could get the decimals for it, but I'm going to show you a little bit more advanced way that doesn't involve writing crazy decimals. I can't do anything here to this side yet. To the right side, I'm going to factor out my x. So I've got tangent of 48 minus tangent 40. Now I can divide by the whole set of parentheses. And now I'm going to go to my calculator. And what's left on the right side is just x. Probably should write that up the other way. And the left side, I'm putting into the calculator. Make sure when you're doing ones like this, you don't forget to close parentheses, because I just did. And I get 30.9 equals x. So that's x. That's this distance here. I'm going to use that here to get h. Tangent of 48 equals h over 30.9. When I do this on the calculator, I'm just going to use previous answer. So I'll multiply both sides by 30.9. So I'm using previous answer because then it's going to use the non-rounded off version in my calculation. I stick that in and I get the height of this guy. Oops, one more than I meant to. The height of this penguin is 34.32 feet. And that's my height. That's my final answer. So again, I drew the triangle. There were several steps on this one. Okay, this is one of the harder ones. But I was able to write my equations, solve them to set them equal to h, and then I can set them equal to each other. And then it's algebra. And yeah, the algebra in the trigonometry unit is probably the hardest part, is putting all the algebra together and doing it with sines and cosines and tangents in them. Okay, navigation, using trigonometry and navigation. You're going to hear this term bearing. And bearing takes a point, and this is how it's done on a compass, and measures it angle from true north going clockwise. Yeah, that doesn't fit how we measure angles on a coordinate plane or any other angles in math, but that's how bearing is measured. Bearing was not invented by mathematicians. It was probably invented by navigators, and it's been this way for a long time. So bearing goes this way, and a bearing of 270 would be over there. Okay, 270 degrees. Make that actually neat. 270 degrees. Okay, which is due west. So a U.S. Coast Guard patrol boat leaves Port Cleveland and averages 35 knots, traveling for 2 hours on a course of 53 degrees, and then 3 hours on a course of 143 degrees. What is the bearing and distance from Port Cleveland? Okay. So first thing, 2 hours at 35 knots means 70 nautical miles. And I'm fine with just leaving this in nautical miles. I'm going to say NMI. The bearing is 53. 35 knots for 3 hours. This has a bearing of 143. So again, I'm going to put in due north. And then I'm going to subtract 90 off that. And oh, it's 53 again? That's almost surprising. I didn't realize that. Um, yeah, they got 37 down there. That works too. And this one now is 105 nautical miles, 35 times 3. I think I'm going to take the units off here. It makes it confusing to read. And we're just going to keep track of that this is in nautical miles. So it wants AC, this distance. Now, they were really nice and gave you a right angle here. Because these are both 53, this is 37. Because the two angles, 53 and 37, add to 90, and this other angle is 90. Otherwise, we would have had to do this like we did vector addition at the beginning of the year, or there's an application coming in the next chapter called the law of sines and cosines that would have allowed us to do this. But here we've got a right triangle. All I have to do is the Pythagorean theorem. This side here is C. That was really, really nice of them. And that gives me that distance is 126.2. Now, I do need to find this angle because it wants the bearing from where we started. So I know that that angle, let's call it x, that the tangent of x is equal to opposite over adjacent. So x is the inverse tangent. And I use the inverse to get the angle always. And the inverse tangent of 105 divided by 70 is 56.3. My bearing is not 56.3. That's my angle inside this triangle. My bearing takes the whole thing from true north. So bearing, I got to add the 53 to it. And I get 109.3 degrees is my bearing. It's 126.2. That wasn't supposed to be degrees here. This was supposed to be nautical miles. Here, yeah, need to use units. Make a little more room here. And if you remember right from section 4.1, a nautical mile is a minute of longitude at the equator. So a 60th of a degree of longitude. And it's just a nice way of measuring on a globe as opposed to a mile. Mile's pretty random. So, okay, that is the conclusion of 4.8. And that is applications of trigonometry or right triangle trig word problems.